This is the second video for section 2.1. In this video, we will identify quantified statements, and we will write the negation of a quantified statement. So we will pick up in this video with quantified statements first, and then example 4. So a quantified statement is a statement including a quantifier. Well, now I better tell you what a quantifier is, right? A quantifier is a word such as all, none, every, some, or at least one. You're basically making a statement, but saying the statement only applies to some items, or maybe it applies to all items or no items. There are two kinds of quantifiers. A universal quantifier is a word such as all or every. Universal quantifiers signify that all items share a characteristic. Contrast that with an existential quantifier. An existential quantifier is something such as some or few. Existential quantifiers signify that at least one item has a certain characteristic. So a visual diagram, such as an Euler diagram, can be used to visualize statements. Now it looks like a Venn diagram. The Euler diagram, though, is helping to show relationships between objects and characteristics. Example 4. Identify the quantifier in the following statements. State if the quantifier is a universal quantifier or an existential quantifier. And finally, create one possible Euler diagram for the statement. So consider the statement, there are no aliens in our solar system. The quantifier here is the word no. We are saying that of all the aliens, none of them are in our solar system. So this is a universal quantifier. You're saying that all aliens share a characteristic. That characteristic is not living in our solar system. Okay, so I have all that written down for you. Here it is. So the quantifier is no. It is universal, and all aliens share a characteristic. So finally, let's create one possible Euler diagram for this statement. Okay, so the two things going on here are aliens and our solar system. And we want to show the relationship between those two characteristics, aliens and our solar system. So your circle for aliens needs to be completely separate from your circle for our solar system. We are saying that all of the aliens, so all of the things that fit in this circle, right, none of them fit in our solar system circle. So the important thing here is that there's no overlap between those two characteristics. Okay, example B. Some horses that run the Kentucky Derby take longer than 2 minutes to run the course. So the quantifier here is some. We are saying that there exists a horse that takes longer than 2 minutes to run the course. Not necessarily all horses, just that there exists one. So that is an existential quantifier. Okay, I have all that written down for you here. The quantifier is some. It is existential. So there exist horses that meet this characteristic. Now there's a couple ways we could draw this Euler diagram. Let's try to draw it in the way that makes sense. So the things we're talking about here are horses that run the Kentucky Derby and the ones that take longer than 2 minutes to run the course. So I'm going to start with horses that run the Kentucky Derby. So this is the set of horses that run the Kentucky Derby. So now the other characteristic going on in this statement is taking longer than 2 minutes to run the course. So we need to decide where that circle goes, right? Where that set of horses exists. So these horses are running the course, right? They are running the Kentucky Derby. They just happen to take longer than 2 minutes. So I'm going to put those guys completely inside this other set. Because they are running the Kentucky Derby, right? So they need to be inside this larger circle. They just happen to take longer than 2 minutes. And notice that isn't all horses. All we're saying is there exists at least one horse, right? Some of them that take longer than 2 minutes. So here is a possible Euler diagram for that situation. That concludes this example. Let me take a moment and talk you through this table. This table comes directly from the text. So this table summarizes 4 statements you could see. These are 4 quantified statements. And then what is needed to prove that false. And then the general form of their negation. Remember that a statement and its negation have opposite truth values. So assuming these original statements are true, we want to find out what would it take for that to be false. And that would be the negation of the statement, right? It would have the opposite truth value. So I think I want to walk you through one of these. I think I'll choose the first one. And I'll draw you some Venn diagrams and talk about why it works the way it does. So what if your original statement is all flowers are red? So let me draw that for you over here. All flowers are red. That would be that inside this red circle will live lots of things. Fire trucks and blood and all kinds of red things, right? But specifically, all flowers live inside that red circle because all flowers are red. So now let's think about what it would take to prove this false. So to prove that statement false, you would need to find just one not red flower. So to prove this false, you need just one, or we could say at least one, not red flower. Could be yellow or green or blue, you don't care, as long as it's not red. So that Euler diagram, that would be, okay, here's all of your red things, and maybe some flowers are in there, but there's at least one that isn't. Right? And these would be your not red flowers. Those would be your blue and your green and your yellow flowers. So that negation reads that some flowers are not red. Specifically, it's these ones here that we just shaded. Right? So this table maybe could help you as you're getting started with the original quantified statements and the general form of that negation. So example 5. Write the negation for each of the following quantified statements. So there are no aliens in our solar system. That negation would be that, well, there has to be an alien in our solar system, right? So the negation would be there are some aliens in our solar system. This one falls into the third one down here, that no aliens are in our solar system. So that negation is some aliens are. Okay, example B. Some horses that run the Kentucky Derby take longer than 2 minutes to run the course. So this falls into the second one down, that some horses take longer than 2 minutes. So that negation would be no horses take longer than 2 minutes. So I have this written down. Let me bring it over for you. So no horses that run the Kentucky Derby take longer than 2 minutes to run the course. Now, you might think that's phrased a little funny, and if you're very careful, you can rephrase these negations. Again, you have to be very careful in thinking what the first negation says. It says that no horses take longer than 2 minutes. I could rephrase that to say that all horses run the course in 2 minutes or less. Again, as long as you're careful, you can use the English language to rephrase these negations in a way that makes more sense. That concludes example 5.